G'day everybody, Mr. Bennett here. Today we're going to be looking at exercise 4D5 and this is a combination of basically the whole chapter here, I suppose. So what we're going to do there is use the sine model here, and over the 10-week period, so 0 to 10 weeks is the information here. So we're looking at modelling a species of insects. Alright, so the first thing is find the initial population. If I was going to do something like that, part A, what I'd need to do is I'd need to look at the time when t is equal to 0. So if we're looking at that, so part A, coming into here, and we're pretty well going to say when p of 0, because that's at the initial time, we're going to have 3 plus 2 sine of, now when you put 0 in there, 0 times anything is 0, so sine of 0. Now what do we know about sine of 0? Well, that's actually going to be equal to 0 itself. So therefore the initial population is going to be 3, and it's 3,000, because that's the units that we're using there. Alright, so we've got 3,000 insects, starting off looking at that thing there. Now, looking at our model here, what we can see is that obviously our sine t function, what's the biggest sine function you can actually have? Well, the biggest sine function you can have is going to be equal to sine of any of that value is going to be 1, and the smallest sine value you can actually have is going to be -1. Alright, so find the smallest and largest population size. So for part B, what we're looking at there is population of t is going to fluctuate between 3 plus or minus 2, isn't it? So therefore that's going to be 5,000 and it's going to be 1,000. So it's going to be somewhere between there is what our population is going to do from there. And then the next bit, it actually asks us to find the intervals when the population exceeds 4,000. So what we're going to do is we're going to put this formula into the calculator and we're going to graph it because that's what we want to use. So the formula is 3 plus 2 sine, now it's pi t, or pi x, divided by 2. Okay, now we have to set our window for this. Now we know our window is going to go from, say, -1, it's going to go to 10. So let's go to 11, so we've got a little bit more room. Our y value, let's say we go -1 up to, the maximum is going to be, say, 6, so let's go to 7. Alright, and we're going to graph that function there, and you're going to see the population over here modelled. Now, it's important that you've got your calculator in radians. If you don't have your calculator in radians, it's not going to graph properly. Alright, so that's our graph, and what we're looking for is when the population is going to be greater than 4,000. So if we draw a line y equals 4,000, that will intersect with that particular line, and we can find those intersect points. Okay, and I should graph that. What's going on over here? I've got my line there and I've got my line 4,000, so it should actually, the reason being it's drawing a line at 4,000, so what I want to do is I just want to draw a line at 4, not 4,000. What a goose. So what we're looking for is intersection points there. So at 4, I've got to find all those points between 0 and 10. What I might do over here is I'll just take a screenshot. I'll just copy that and I'll paste it into our document over here. Change this over here. I'll just paste it in there, make that a little bit bigger. Just make that a bit bigger. Alright, so you can see the graph, and that's what it's expecting you to do, is actually graph that. Now, whether we're looking at UV radiation levels or we're looking at populations and that sort of stuff, so obviously the bugs are going to go in a cyclic nature here. So we need to find these points. Now remembering you've got your calculator and you can do this on here. So we go to our calc button, we've used this a fair bit, go to number 5, intersect point. Let's start at the end. I don't know if I'll find all of them, but let's just find some of them anyway. Alright, so if I'm over that minimum, enter, enter, and enter, don't want to make a guess. So that's going to tell me that's 0.333. So if we're looking in our graph over here, so that there is going to be 1/3. Alright, so that point down here is 1/3. And then go to find our next point. Alright, so just close that. So again, calc. So you can quickly do it. It's a lot easier than trying to do it algebraically, which you could do if you really had to, but we don't have to because it's expected that we know technology. 1.66, so that's like 1 2/3. Right, so we might want to write that as 1 2/3, or you could write that as like 5/3. Okay, there's a probably more accurate way of doing that. You get the idea? So we're going to be labelling points where it's above 4,000. So when you're doing it mathematically, the time is when time is greater than 1/3, less than, or greater than equal to, because that. So that's the first time interval, and then I have to find that time interval. Now, considering we're going to probably be adding on, what, 0.2 or something like that, let's just find one more point, just to show you it's not that hard to do. Number 5, and we're scrolling across, so we've got to go other side of that little minimum. Okay, enter, enter, enter. So that's going to be 4 2/3. Sorry, 4 1/3. So I'll go back to my graph and I can label that as 4 1/3. And so without really doing much more, we know that's going to be what? That's going to be, that was an extra 2.5, so that's going to be 5 2/3. So this next one will be 8 1/3. So that's going to be 9 2/3. So you've got those intervals now where you can actually find that. So the cyclic nature actually helps us. It saves a bit of time. So 4 1/3 and 5 2/3, 8 1/3, and 2 less than 9 2/3. So those are all the intervals when the bugs in the week. So between 1/3 of a week and 2 and 1 2/3 weeks is the time when the bugs are going to be over a population of 4,000. Alright, now if you look at the chapter itself, there's a whole heap of different types of questions. So number 2 looks at modelling the population of water buffalo in the Northern Territory. Obviously they're pests, so I want to make sure they're not too big. Question 3 is looking at modelling UV radiation. Alright, so that's actually quite a good question. Make sure you do that one. Question 4, looking at certain time intervals, the cost per litre of petrol. Alright, so that's a cyclic nature where we know that there's a cheap day to buy petrol and an expensive day to buy petrol. So these are all examples of where you're using a sine function. And there's a couple more challenging ones for you to have a go at doing as well. Alright, so have a go at those. If you need some help, make sure you catch up with me.